Hi there, welcome to the Exam AZ-900 Microsoft Azure Fundamentals Study Guide. This is episode 10 of 63, Azure Compute Products. My name is Tim Warner. Where are we in the Exam AZ-900 objective domain? Well, we're still in the functional group Understand Core Azure Services. The objective is describe some of the core products available in Microsoft Azure, and our specific skill today is describe products available for compute, such as virtual machine scale sets, app service, and functions. As you see on the right side of the slide, timw.info/AZ900 takes you to a GitHub repo I own where I make this Excel workbook available to you for fun and for free. Let's proceed. What is compute and how does this relate to the Microsoft Azure public cloud? Well, if you've been following the study guide sequentially, you know that Microsoft Azure gives us consumption-based access to virtual computer resources, particularly the central processing unit, the so-called brains of any computer, random access memory, which is higher speed scratch space, storage, virtually unlimited storage thanks to the Microsoft Azure public cloud's resource pooling, and again, network bandwidth at various levels of service level agreement. Some of the benefits we know of the public cloud is that you don't have to buy and maintain, secure, and back up all of that hardware. Instead, the hardware is running in Microsoft Azure data centers located in, you'll remember in the previous lesson, Azure regions around the world. Some questions to ask yourself when you're considering consuming Microsoft Azure Compute are things like, what is your need for control over the underlying operating system? Microsoft Azure supports various versions of Windows Server, Windows 10, the client OS, and also several endorsed Linux distributions. You may have special applications, custom software, that's not natively supported by Azure Platform as a Service or PaaS products. In this case, there's nothing stopping you from deploying one or more virtual machines or VMs and installing the custom software there. But as an Azure solution architect, I always surface to my customers the question, let's say you're running a LAMP stack application so that you're accustomed to using Linux, that's the L in LAMP, Apache Web Server, that's A, MySQL, that's MySQL, the relational database, and PHP is the P in LAMP. Well, why not consider using, say, Azure App Service to host the application and using MySQL? There's a few varieties of hosted MySQL available natively in Azure. You see what I mean? So you don't always have to go to the virtual machine scenario is what I always try to stress. That having been said, virtual machine, if you don't know, is a software representation of a hardware computer system. You could look at it as an emulation if you want. What you've got are hardware computers that run the Hyper-V hypervisor software. Hyper-V is a Microsoft hypervisor, of course, and in your Azure regions, in your Azure data centers, in those hardware hosts, live any virtual machines that you deploy to the region in Azure. Microsoft provides the hardware infrastructure and the features, but as part of the shared cloud computing responsibility model, we as customers need to apply those tools to provide high availability, security, and disaster recovery for our virtual machines. At the right side of the slide, you can see a sample reference architecture diagram with an attribution URI. Looks like there's a typo there. It should be timw.info/HVA. And you don't need to know all the specific parts and pieces. Remember, Azure Fundamentals is a general skill set, but if you do plan to be doing at least a good portion of your work in Microsoft Azure, you should become familiar looking at these diagrams. And this one is showing a hybrid cloud where we have an on-premises network at left and a site-to-site virtual private network or VPN connection into an Azure Virtual Network or VNet. And it looks like we have a total of 4 virtual machines deployed. 3, the ones that are over on the right, represent some kind of web tier workload, and the NVA virtual machine in the middle. NVA stands for Network Virtual Appliance, and this is a special purpose VM that's performing perhaps something like load balancing or enterprise firewall services for the other resources in the VNet. We recall finally that when we use virtual machines in Azure, this is called infrastructure as a service, and as I said, it's up to you to back up and secure those virtual machines. That's not Microsoft's shared responsibility. There's an alternate deployment for virtual machines in Azure. What I just showed you was the one-off approach, but you can also orchestrate virtual machine lifecycle. This is called the Virtual Machine Scale Set, or VMSS. And this is a group of identically configured load-balanced VMs. As you see in the diagram at right, you've got an Azure load balancer that exposes the scale set behind a single IP address. That single IP could be a publicly internet accessible IP address, or it could be a private address that's accessible only within the virtual network. But the business case here is that you may need high availability and scalability in an IaaS environment. In other words, your scale set might be hosting your corporate website. And as traffic spikes happen, you want Azure to automatically spawn or clone the virtual machines to spread the load out and to give your users a better experience. That's auto-scaling, and you can do that with VMSS. You can scale out, and you can also scale in. Another use case for scale sets is when you have stateless batch processing jobs. Let's say once a month you need to crunch through quite a bit of compute power. It's a good idea in that case, perhaps, to run those jobs in parallel across n number of virtual machines in a scale set. Stateless means that you're normally hosting the data externally in, say, an Azure storage account, as you can see in this diagram. Because the idea with stateless VMs in a scale set is that you can scale them out, scale them in, and destroy them. And because you're not storing the line of business data on the VM, that's perfectly okay to do. You're just taking advantage of the virtual compute power, the CPU, the graphical processor unit, or GPU potentially, and random access memory, or RAM. Next, we have Platform as a Service. The keynote feature family there is called Azure App Service. Sometimes it's called Azure App Services, plural, but it's the same thing. This is a hosted environment for web apps, background jobs, mobile backends, and RESTful APIs. We learned a little bit about what a REST API is and what Azure Resource Manager is in another installment of this series. Under the hood, you've got what's called an app service plan that's providing the compute, but you really don't get a whole lot of access to the underlying compute. Instead, the idea is that you can focus specifically on your code, on your application, and particularly how that application behaves. For instance, you might be building and deploying this application using, say, an Azure DevOps continuous integration, continuous deployment, CI/CD pipeline. That subject of Azure DevOps and CI/CD is another whole kettle of fish for another time. It's not on AZ-900, so let that go if you don't care about it. Lastly, the Azure Function is an example of serverless computing. That's a pretty popular buzzword nowadays. The idea is that you're doing code as a service, where you're hosting simply a code file that contains source code written in your development language of choice. Azure Functions supports several different development languages. And then you have the function triggered based on an event. For instance, in the diagram at right, you've got a web application that, depending upon what the user is doing in the application, it might trip off a function app. And that function app, you can look at it as a Swiss Army knife. That code can do whatever you need it to do. Copy data into a Cosmos DB database, send an email message notification, whatever it is. The benefit is that you have just about all of the compute abstracted away. In fact, there's two types of pricing for Azure Functions. There's a consumption-based pricing where you get a free tier of a certain number of function trigger executions, or you can do app service plan where you're prepaying for a fixed amount of compute per pay period. Depends. How you would choose one or the other is more of an architecture question. I want to now take you out into the Azure portal and give you a brief tour of each of these compute models in Microsoft Azure. Alrighty, let's get this party started. I'm going to give you a trolley ride through Azure Compute, looking at the main services, starting with virtual machines. So in the Azure portal, let me use the global search, look for virtual machines, and notice that we have separate nodes, or separate blades, to use the correct term, for virtual machines as well as virtual machine scale sets. In this demo, I'm just going to focus on virtual machines. I've deployed an Ubuntu Linux-based virtual machine called My Docker VM, and as you can see in the list, we see some basic metadata. You can change the metadata that shows up in your resource lists by clicking Edit Columns, and then picking additional columns for instance, availability zone, and bring that over to the selected columns list as you see over here. Now note that any view customizations you apply in the Azure portal are going to be relevant only to you, the current user in the portal. Now, if we go into my Docker VM, let me show you how compute is manifested. If we come down the settings list down to size, let me adjust it to there we go, to size, we can choose a different virtual machine based on filters. Now, I've shown you this in the past, so I'm not going to spend an awful lot of time here. Notice the message down below. It says that the prices are actually estimates, and they're also shown in your local currency. The idea here is that you can use these filter controls to say, for instance, show me only VMs from a particular family, like high performance compute, let's say. Looks like I'm showing two, general purpose and high performance compute. Let me deselect general purpose. Now, you may not see anything when you do a filter because also it's going to be dependent upon the region that the virtual machine is, and not every virtual machine size is in every region. And also depending upon your subscription, you might have limitations there. Long story short, each of these VM sizes is characterized into a family, and you'll see that you can choose among different balancings of CPU, RAM, number of data disks, input, output operations per second, etc. And the idea is you can choose a size, click resize. Azure will reboot the VM, so be aware for a temporary denial of service, and then you're off and running with the new size. And you can monitor how the size is behaving right on the overview page. If you scroll down, you see some views here for CPU, network, disk, and disk operations, and so on. That can give you a snapshot into how utilized the compute is. Because the idea is that it's a balancing act, especially with virtual machines. You don't want to pay for too much compute, and you don't want to pay for too little. Another thing I want to show you here is Azure Bastion. If I go to Connect and then select Bastion, Bastion is a separate managed VM that optionally you can deploy into your virtual network, and it allows you to connect to a management port on the virtual machine directly within the Azure portal. This is a Linux machine, so I'm going to do a secure shell connection. So what I'll want to do is on the Bastion tab, supply a username. I am using password-based authentication and not an SSH key. So I'll carefully type my password and click connect. As of this recording in March 2020, Azure Bastion functions only within the browser, as you can see. But now I've got full stack access to this virtual machine. I could just as well have connected over the internet if the virtual machine has a public IP, but I'm just trying to drive home that the virtual machine scenario, I've got full stack access to the operating system and environment. Okay, now let's go over to the app services blade because I've got a couple app service apps running. I've got a WordPress site happening here on this particular machine. And if I click Browse, it should load up my blog's homepage. And I just created a simple WordPress blog using a MySQL in-app database that all is hosted for you directly in Azure. That's perfectly fine. The way you get to the underlying compute here is if we come down into Settings and go to Scale Up. This happens in the context of the app service plan, as I said before. And these pricing tiers, as you can see, are going to give you a certain number of Azure Compute units, or ACUs. That's a relative metric of performance. Because, you'll never know exactly what the hardware configuration is of the underlying hosts. That's part of the abstraction of the public cloud. But you get more ACUs depending upon your pricing tier. You get more dedicated memory, and you also get features that light up as you improve to a higher pricing tier. All right? So that's one way to interact with the compute. Another way, actually, is to use a kudu console, as it's called. Notice that we can tap into a command prompt to interact with the file system on this virtual machine. If I do a directory listing, I see a bunch of PHP and text files. That's because, as I said, I'm running the WordPress blog software on here. You also can come up a little bit to Settings. Actually, it's Configuration. And we can make changes, for example, to the underlying runtime environment on General Settings. If it's a .NET or .NET Core or PHP application, this is a PHP application. But as I'm scrolling through, it just gives us a bunch of graphical controls where you can make changes, but it's a different paradigm from working with a virtual machine. Here in this case, we're working primarily with the source code itself. Notice that there's a deployment center option where it looks like the code for this WordPress site is stored in a GitHub repository, and I can create a separate Git repo hosted anywhere I want, GitHub, or I could host it directly in Azure App Service. That's what the kudu, K-U-D-U, signifies. Or I could use another source. It really doesn't matter. But once again, the idea with Azure App Service is that you can focus more squarely on your source code and the functionality of your app, as opposed to getting lost in the weeds of the underlying compute. Lastly, let's come back to app services. And let me show you very briefly. Actually, I go to the function app blade. I've got a function app running. And this, again, as I said, is code as a service. The user interface here is wildly non-standard compared to the rest of Azure, unfortunately. And the idea here is you create a function app and you associate the app with either an app service plan, or if you're using the consumption tier, you can do that. Notice that at the function app level, you can get to your settings and your platform features here, including console. It's important to understand that Azure Function apps are part of the app services family, just like web apps that you deploy under app service. So again, most of the compute is abstracted, and instead what we have with the function app is essentially a container into which you can deploy a number of individual functions. You have just a single code file, as you can see here, and you choose which runtime environment you want to use. I chose for this timer trigger one function, PowerShell. So as you can see, I've got some sample code here that just basically echoes when the function trigger was kicked off. If you click logs, you can view the streaming log service, and we can kick off the trigger manually by pressing the run button, and it just echoes back what's in here. Timer trigger ran. This line here on 13, it's writing out PowerShell timer trigger ran, and that it echoes the current UTC time, and you can see that down below. Learning resources. Well, these learning resources are a little bit different. At first blush, you might think, whoa, these are way too advanced for Azure fundamentals. And there's a point to that argument, but hang with me. The Azure Architecture Center, timw.info/ARCH, is a great reference for those who want to use Azure to develop solutions for customers. But I also want you to look specifically into the Architecture Center at the reference diagrams, because once again, I want you to get comfortable looking at different real-world topologies or real-world use cases of Microsoft Azure. And it's a great way to improve your general understanding of Azure and your general familiarity. Second, Microsoft Press publishes a free ebook on serverless computing, timw.info/FEB. And again, let it go if it's too technical, but if you will have any need to understand a bit more about how Azure implements serverless in general and function apps in particular, you might want to take a look. Thanks as always for your participation. You can reach me at Twitter at TechTrainerTim. I post on Microsoft Azure just about every single day. My Pluralsight courses on Azure and other technologies. I am, after all, an IT generalist. You can find that at timw.info/PS. And my website, including contact info, is techtrainertim.com. Take good care. Happy studying.